We are going to take a perfect example of maximum sum array to understand time complexity. We are going to start from n cube and we will go till O of n, and I will explain you the entire journey. So let's get started. Let's first try to understand what is this max sum problem. This is a very classic problem. So given an array of n elements, our task is to find the maximum subarray sum, that is the largest sum of sequence of consecutive values. This is very important. Consecutive values in a given array, and we need to find the maximum sum sequence, correct? If you look at this particular array, if you select this particular sequence of consecutive values, the sum will be the max. You try to select any other consecutive numbers and sum will be less than this particular sequence, right? Let's try to take few examples. See, here we have 2, 4, minus 5, 10 and 7. The total sum of this is going to be 18. Now we can select these two, 4, 10 and 7. That will result in 23. But that's not the problem is. We need to select the consecutive values. You need to select minus 5 so that you can have this entire sequence. So you need to select consecutive numbers in such a way that their sum is going to be maximum among all the possible combinations of start and end. So here start is this and here end is this. So you take all the other combinations for starting point and ending point and compute the sum, and finally you take the largest among those. I hope the problem is clear. So let's look at first solution. Now the simple way to solve this problem is to go through all possible combinations of the start pointer and end pointer, compute the entire sum in between, take the value and compare with the final answer. Keep on updating this answer. Let's say this answer is less than the value, then update the value of answer to the value. This value is sum of all the consecutive numbers between the start and end. Right? You vary this start, you vary this end, you try all possible combinations and update the answer. Let's try to code it. We have start pointer, we start from 0, goes till the end. We have end pointer, which starts from the start and goes till the end. And we are going to have another for loop inside this, which will iterate on all the numbers from start till end. And we are going to compute the sum. We store that value sum into a current sum variable and we finally update the answer. Exactly what we saw, right? You take one pointer, that is start. You take another pointer, that is end. As per the question, we need to take all the elements from start till end and we need to compute the sum. So we are going to take another pointer as k, and this k will start from here till here. So k is going to be an iterator that is going to iterate from left to right, and it's going to compute the final sum, right, that we are going to store in current sum value. Now we check if this current sum is greater than the answer we have, then we are going to update the value of answer. So ultimately we will have the answer as the largest possible sum among all the possible combination of start and end. We will vary this start and we will vary this end, and we have this iterator k that is going to start from the start pointer and end on the end pointer, and is going to compute the entire sum, and we are going to update the answer based on our current sum value. Let's look at the time complexity. Now if you observe this inner loop, this starts from the start, right, and goes till the end. And what operation exactly it's performing? An addition. Addition has nothing to do with the input length. Input length is n, correct? This exact operation is going to take O of one time, right? And we have a for loop here that starts from the start and ends till end. So there is one for loop. In worst case scenario, it's going to take O of n time. Again, you have another for loop. This end. This start from the start and goes till end. So initially, end will vary from 0 to n minus 1. Then start will increase and it will be 1. So n will vary from 1 to n minus 1. Right? So here you have n with different values. Here you have n minus 1 different values. So n after that is going to take n minus 2 different values. So it's like n plus n minus 1 plus n minus 2 till you have 1. And sum of this is n into n plus 1 divided by 2. Now we have already seen in time complexity what we don't care about the small numbers, right? Because this n square is very huge compared to O of n. So again, this section is also going to take O of n time. So this takes O of n time and this also takes O of n time. Now this outer loop you can clearly see that it starts from 0, goes till n. So definitely it's going to take O of n time as well. We start from the innermost for loop. We look at this plus addition. We know that it doesn't depend upon the input size, that is n. So it has nothing to do with n, right? It's just a plus operation. So we know that this plus operation is going to take O of 1 time, which is constant amount of time. And it will be executed n times. That's why this entire inner for loop is going to take O of n time. This outer for loop will also run O of n times. Whenever it runs, it executes the inner loop and it takes O of n time. So for single execution, this inner loop is going to take O of n time. And how many executions are there? O of n, right? This end will start from start and goes till the end. When end is equal to start, this inner for loop will be executed completely. That will take O of n time. After that, end value will be incremented, correct? Then end will become start plus 1. Again this entire inner for loop will be executed and that will take O of n time. So the inner for loop takes O of n time for single execution and we are executing it n times. That's why this entire inner section is going to take n square. Same thing for a single execution of this inner end loop is going to take n square time complexity and start is varying from 0 till n. That means this n square execution will happen n times. That's why the total time complexity is going to be n cube. I hope this is clear.